Welcome friends, so let me show you how to relate, for example, like y prime is given to you in some form like say y times 2 minus y, and then we want to relate this to the direction field in the wholesale fashion. So one thing you should observe is that this is equivalent to just writing the following, distributing, you're going to have 2y minus y squared, which is just negative y squared plus 2y. If you look at this expression, this is just a parabola essentially, you see? So that means it has the characteristics of a parabola, which means what we can do is plot as follows. Let me show you. So here put y because that's the independent variable here, and then on the vertical what gets output is y prime. That's the slope essentially. Now let's look at this. So here when y is 0, then this is 0 right here, and then when y is the 2 minus y, to make that 0, well, y has to be equal to 2, so this is 2 right here. So y is equal to 0, and then y is equal to positive 2. Now, because this is a negative leading coefficient right here, that means the parabola is going to likely do something like this, you see? Like that. So what are the roots of this expression correspond in terms of a vector field to something like this? Let me draw in blue. When you have a vector field, the roots of this, so let's see. When y is 0, so here now this is y and this is x. Be careful with that. This is y prime versus y, different graphs representing related information. So this is y equals 0 right here. This is y equals 0. The other root is right here, is positive 2, see? So y equals positive 2 is this one right here. So y equals positive 2. Now along there, because this is the slope, y prime versus y, along there the slope is 0. So in terms of the line segments, you would basically mark them this way, horizontal line segments along both of these lines. But then you want to sketch the slope field using this around these. So what you can do is make some key observations. For example, since this is 0, this is 2, this is likely 1. You can check for yourself if you like, but you see that's the maximum value of y prime right here. So it means, and this corresponds to a value because y is on the horizontal in this context. This is y equals 1. So that means in the slope field picture, when y is equal to 1, which is this line, right, y equals 1, you're going to have the maximum possible value for the slope. So the steepest that you can be, whatever that is, you can find it as follows. Just evaluate this at y equals 1, so it's going to be 2 minus 1, which is 1. 1 times 1 is 1. Now look very carefully. Like, what does this little segment right there tell you? That's going to tell you something about the slope field picture, this segment. Well, it's very small, but it's still positive. So that means right here, because this is close to 0, this is a small positive value. That means here that these little segments will have a positive slope, but the positive slope will be very gentle. Now look what happens over here. Again, this is still a positive value, but it's very small. So that means when you get close to y equals 2 in the slope field picture, you're going to have little segments, but they're going to have a very gentle slope that looks like this, you see? And the maximum slope occurs at y equals 1. And then hopefully you can tell that the flow lines look like this pretty much, you see? In terms of a few pictures. All right, now besides this, look what happens over here to the right of y equals 2. Let me stress, on the horizontal we have y value. Here in this picture, on the vertical we have y values. So a little bit different, keep that in mind. For example, you see these segments basically are telling you that as y goes towards infinity, which in this picture means we're going up this way, then the slope values, which is what y prime is here versus y, the slope values become ever more negative. You see? So in other words, they look like this at first, like this right here. That means it's negative but very gentle. So like this, okay? Negative but very, very gentle. This means it's negative but bigger. So that means when you draw the little lineal segments here, you make them a bit more negative like this, okay? Again, this is now getting ever more negative above y equals 2, which in this picture corresponds to being above y equals 2. So that means when you draw those segments to indicate the slope field, you have to make them, ever bigger like that. Which likely means that the solutions flow together like this, you see, towards y equals positive 2. Now relate the last piece. What happens over here? So here again, this is a negative value. It's below the y-axis, but it's very small in absolute values, very close to 0. So it means when you draw the slope field here, you're going to draw segments with a negative slope, but a very gentle negative slope. and then it gets ever more negative. You see this? Like this here, it gets ever more negative. That means, again, when you draw the little segments here, you have to make them ever steeper, but still negative, okay? Ever more steep, but negative. And then you have a situation that kind of looks like this in terms of the flows. See? So that's how you can relate the parabola, basically, that represents y times 2 minus y to the slope field picked. The way you draw, for example, the slopes, let me stress this. So let's say this is y equals 3. So y is equal to 3 right here, okay? Then that would look like this. You would have 3 and then 2 minus 3, which would be from here, 3 times negative 1, which is negative 3. That means like the value in terms of the parabola right here is, this is what, negative 3 right here, y prime. But that means in the slope picture, since this is y equals 3, a positive 3 in the slope picture, so this is 1, this is 2, so 3 is here. That means along y equals 3, every little slope lineal segment would have a value of negative 3. That's why they're all looking like this. That's it for this one, so please be sure to like, subscribe.